Hello, everybody. This module is going to deal with momentum, which is module 7, and it equates to chapter 7 in your textbook. Momentum itself, you'll find it's quite simple to calculate, but I want to give you a little background with it too. There's something called the impulse momentum principle, and that equates to a formula. That formula is F delta T equals M delta V, where the F delta T represents the impulse, that is force times the time the force is applied, and that equals M delta V, which is a change in the momentum of the object. This all centers around collisions. If we think about, say, teeing off in golf, when you swing the driver and the driver, the club head comes in contact with the golf ball, that's a collision in question. Now, the driver is applying a certain amount of force over a certain amount of time. That force times the time that is being applied is called the impulse. That impulse is equivalent to the change in momentum of the golf ball. In other words, the golf ball is initially at rest, but then it travels after that. So that change in momentum causes the ball to go in motion. Now, momentum itself is just mass times velocity. That's simple. So the object has to be in motion to have momentum. Now, the golf ball, when it's sitting on the tee at rest, it has no momentum. So really, the change in its momentum goes from 0 to something. Now, if I ask the question is, for instance, is there an advantage to following through with your golf swing, or if you're batting or playing tennis, is there an advantage to following through? And that's yes, because you're increasing the amount of time that you're applying that force. If you increase the time, you increase the overall impulse. If you increase the impulse, you increase the change in momentum. Now, when you increase the change in momentum, you're not doing anything to the mass. You're going to increase the velocity of the ball afterwards. In other words, for instance, if you're trying to hit a home run, you don't bunt, because when you bunt, the time span that you're hitting the baseball is very, very short. If you want to hit a home run, you follow through. That way you're applying that force for a longer time. Longer time means longer momentum. You're not changing the mass of the baseball, you're changing its velocity. The greater the velocity, the greater the distance. Same in golf. If you're chipping, you're just trying to get it a short distance. If you're driving, if you're on the fairway and you have 300 yards to go still, you're going to follow through to get the longest possible distance. One thing that students often have trouble with is inferring one from the other. In other words, if you have the impulse, it's going to be the same as the change in momentum. So say, for instance, I give you that you're applying force of 2 newtons for 3 seconds. 2 times 3 is simply 6, and the unit for impulse is newton seconds. So if your impulse is 6 newton seconds, then your change in momentum is simply going to be 6, but a different unit. Because the unit for momentum, since it's mass times velocity, mass is measured in kilograms, velocity is measured in meters per second. And these are equivalent units. They break down to the same thing. So if you're given one, you can infer the other. Keep that in mind as you go through your calculations and through the exercises and problems. But if you just wanted to calculate a basic momentum, say, look at this example here. It says, find the momentum of an object that has a mass of 6 kilograms moving at 4 meters per second. Very simple. Start with your basic momentum formula. We have a 6 kilogram mass moving at 4 meters per second. 6 times 4 is simply 24. And the unit for momentum, again, is kilograms times meters per second. It is that simple. The difficulty comes into play either inferring one from the other, or when it comes to applying it to particular problems. And that's why you get a lot of practice in this module, applying it to one-step problems, but also multi-step problems. And in a minute here, we're going to look at, finding total momentum, and then something called the conservation of momentum.